Welcome back to Statistics. The popular image of statisticians is that they're just a bunch of number crunchers. And while number crunching is certainly part of what statisticians do, it's not the whole story. Statisticians are very involved with all aspects of studies from the very beginning. And this would include the design of the study itself, in addition to the analysis of the study's results. So, for instance, if it were an opinion poll, if, say, we were trying to estimate the support that a certain politician had in the electorate, the statistician would be involved from the beginning in the planning of the study. Statisticians would be consulted on the wording of the questions in the study, the kinds of questions, and so on. Statisticians would also be consulted on the sample size necessary for the study. Because after all, you may not know what a politician's support in the electorate is, but you may know ahead of time that you would like to estimate that support within a certain margin of error, like plus or minus 3 percentage points. In order to do that correctly, you've got to have the appropriate sample size, and statisticians would be involved in determining what that sample size would be. We can already see this in action in examples involving confidence intervals of the sorts that we've been computing recently. So let's take a look. Design of studies. So in preparing for a statistical study, we often have requirements both for the confidence level that we'd like to report our results at, as well as the precision of the estimates that we want to make in the study. For example, we might want to estimate the mean selling price of a home in a certain town with 90% confidence and with a margin of error no more than $2,000. We can use what we know about the margin of error to determine the sample size n that's necessary in order to make the estimate in accordance with these requirements. So what would that involve? Well, it basically involves the mechanics of the margin of error. The margin of error has two factors that are under our control. First is the confidence level. We know that increasing the confidence level tends to increase the the margin of error, while decreasing the confidence level will decrease the margin of error. And we also have under our control, if we're planning a study, the size of the sample that we're going to use. And both those factors play into the formula for the margin of error. The third factor is the standard deviation in the population, and usually we don't have any control over that. But the confidence level that we desire determines the critical value z star. And so if sigma is known and we have a desired margin of error m that's given, then we can solve for the sample size n that will give us the desired margin of error at the desired confidence level. Here's an example. Suppose that Jack wants to estimate the mean selling price of residential real estate to within plus or minus $2,000 in a certain locality. He's willing to assume that the standard deviation of the selling price is $50,000. And he desires a 90% confidence in his estimate for the mean. How large should Jack's sample be in order to make the desired estimate? So let's begin by collecting the information that's given. We know that he wants his margin of error to be within $2,000 plus or minus. So that tells us that m is $2,000. Since the prices here are all in thousands of dollars or more, I'm going to go ahead and use units of $1,000. So I'll just say m is 2. We're also given that the standard deviation of the selling price is $50,000. So my sigma is 50. Again, the units here are thousands. And finally, he desires a 90% confidence level in his estimate. So our value for the confidence level is C equals 0.90. That's what's given, and what we want to find, of course, is the sample size necessary, the minimum sample size necessary in order to make this estimate. So how do we get started? Well, first, let's use the confidence level C to determine the critical value Z star. We know how to do this, right? If the confidence level is 90%, then we're looking for the middle 90% of the standard normal distribution, and the upper bound for that turns out to be 1.6449. So our critical value is Z star equal 1.6449. Now let's combine that with the other values that are known and plug it into the margin of error formula. So using m equal 2 and sigma equal 50, along with my Z star value, I get this little equation. We can solve this equation for n, and that'll give us our sample size. So I'll just step through that process real quick. The first thing we have is bring the square root to the other side of the equation. I'll multiply out that right-hand side now. Divide both sides by 2. And then square both sides. And we get a value of n, which is 1,691.0600. So that is the minimum value of n that would satisfy our requirements. But remember, n has to be an integer. And if the minimum value is 1,691.06, and yet n needs to be an integer, we need to actually round that up. So we always round up in these cases. So the minimum sample size necessary would be 1,692. And that would enable Jack to estimate that mean selling price with margin of error of actually a little bit less than 2,000 for 90% confidence. And so we have our design for this study. So that's just kind of a quick example of the kinds of thoughts that go into designing a statistical study. Of course, if the study is more elaborate, the kinds of computations that we have to make may become more elaborate, but the basic idea will be the same. We use known values and known relationships among those values to arrive at the sample size and other kinds of parameters that we would need.